Hello, dear ladies and gentlemen.
Hello.
I greet you after the break and I hope that everyone is well.
Yeah.
Hello.
Nice to hear. Unfortunately, I cannot say same thing about me. My blood pressure plays dirty game with me.
Oh.
I don't know why, maybe because of all these happenings. I'm quite nervous about everything, but I will try to be strong. Okay. As you understand, I also received that email with information about how we should continue our meetings. As you know, we will be having the same type of teaching up to the end of semester. I
Yeah.
hope you received this information as well.
Yeah.
So, what I'm going to do today, I am going to uh, solve more problems, but that particular session is the last session about exponential and logarithmic models, which I'm planning to cover. So, and I am planning to offer you a test for these two last chapters, which we covered. And I'm planning on this week to start trigonometry, and it will be quite brief review, but this review is quite serious. And I told you a long time ago to start reviewing trigonometric formulas, its properties of functions, because again, we will be having a very brief review of trigonometry. So this is my plan, and actually, after we finish our review of trigonometry, it will be a material which probably will be brand new for many of you if you did not take PreCalc before. So, and this will be probably the last topic which we cover in this pre-calculus class. So this is like main plans up to the end of semester. Right now, I can see here quite many names, but at the same time, it all the time updates as new people participate our meeting, and this is why I will be doing this again my traditional way, just calling your names. Today is the April the 6th, and the following people should be in this class. So Andrew.
Here.
Ima.
Hello.
Hi. So Lorraine.
Hi.
Okay. Lynn.
Here.
Juanita.
Here.
Christian. Yuran.
Here.
Gabriel. Divina.
Here.
Kobe. Chantal.
Here.
Ricardo. Hochito. Bonksi.
Here.
Kyle.
Here.
Matthew. Julian.
Here.
Nathan.
Here.
Alejandro.
Here.
Okay. Let me show you that paper, which actually has, in my, according to my knowledge, the last problem which we worked with. And after that, we will continue. Just 1 second. I hope you successfully received the link of the last lecture through YouTube. Did you?
Yeah.
Yes.
Yeah.
Excellent. Can you please help me to update this? Is it that last problem which we talked about?
Yes.
Yes.
Okay. And this was about horizontal and vertical asymptotes. Why is it so important to talk about asymptotes? Because both families of functions have asymptotes. The family of exponential functions, they have horizontal asymptotes. The family of logarithmic functions, they have vertical asymptotes. So, and I would like to offer you right now one of problems. It will be from your textbook, and these are problems from this part from 11 to 14. Here you can see problems number 11, 12, 13, and 14. And let me actually tell you what we have to do here. Graph the functions in exercises 11 through 14. Label all asymptotes and intercepts. And let's see what we can actually see here. And I will start, let's say, with problem number 11. It is quite interesting problem. It represents an exponential function. And let me copy that formula. Again, this is page number 210, section number 5.3, and problem number 11. The formula for number 11, page 210, y equals 2 times 3 to the x plus 1. This is the formula for that exponential function. General or standard formula for exponential function is a times b to the x. What about this plus 1 in that equation? Do we have anyone who wants to answer my question? What do you think? If you have, let's say, function, I'm going to write down the other equation, and this is function number 2, and the top one was function number 1. Equations for function number 1 and number 2 are quite similar, but at the same time, you can see a difference. This is parameter plus 1 at the end, which is a difference between two graphs. I like to ask you to reply to my question. What about a function of this plus 1? What does it do? Let's say if we have already graph of y equal to 2 times 3 to the x. In other words, graph of second function. Do we have anyone who wants to answer?
So,
Does it move the function up?
yeah.
Does it work like a vertical shift?
Yes.
Can we
Yeah.
say that two graphs will be parallel to each other?
Yes.
Yes.
Yes, we can, because parallel can be not only actually lines. Curves also can be parallel. If the only difference is in the shift up or down, we are not changing the width of the graph. It will be on the same distance, let's say vertically, from each point on the graph to y-axis. This y, sometimes when it changes more rapidly than other exponential function, we say graph is more narrow, closer to y-axis. This width of the graph will be not changed. We are just lifting that graph. This y, I will definitely let you graph by yourself, but I will mention quite important properties of that function. What do I mean under important properties of the function? I am going to side by side for each of these functions, number 2 and number 1 list main properties. So this why I also like to ask you to write 2 columns, and for comparison, these columns, let's say side by side, to see what can be changed. I'm talking about this. Side by side, I wrote 2 columns. In one column on the top, you can see y equal to 2 to the 3x. In the second, y equals to 2 times 3 to the x plus 1. And let's definitely start with domain, because domain is one of the most important properties for any function. Can we say that they share the same domain?
Yes.
And what would be that domain?
All real numbers.
Absolutely correct. Yes, Andrew, it is the set of all real numbers. Second here, I would probably like about really also important property, I would talk about y-intercept, because these functions, because this was actually second one was 1 unit up, it also will not have x-intercepts, because function y equal to 2 to the 3 to the x itself does not have x-intercept. If we had 2 to the 2 times 3 to the x minus 1, it will be shift down. In this case, definitely we would have a x-intercept. But in our cases, for both functions, we do not have x-intercepts, none. And this is why we can talk about y-intercept. Let's talk about y-intercept for the first function. What about parameters? What would be a value for first function? It is 2. What is about b value? It is 3. If we talk about second function, and I'm going to actually write down indices so we will not be confused, because if we use same letters without different indices, they are representing similar values. This why we need to be very specific. I will show it to you right now. You can see I have for D, I have D1 and D2. I have A1, A2, B1, B2, and I have first y-intercept. So what would be the first y-intercept if there is no vertical shift? Definitely, it will be equal to the A coefficient. So it will be 2. But now we need to think about the second, the main function which we started with, function number 1, which has a vertical shift. Do you understand that when we shift the graph parallelly 1 unit up, then y-intercepts also migrates to the new point?
Yeah.
Yeah.
Is it just going to move vertically 1 unit up?
Yeah.
Yes.
What would be second y-intercept?
3.
Is it 2 plus 1, which is 3?
Yeah.
Excellent. Now, let's talk about asymptote. Horizontal asymptote, definitely. Asymptote for first function in these columns, 2 to 3 to the x. Horizontal asymptote, is it going to be x-axis itself?
Yes.
What is the equation of x-axis, official equation? Is it y equal to 0?
Yes.
Yes. So, excellent. I wrote it down. What about horizontal asymptote for the second one? Is it going to also migrate to the new level?
Yes.
And what do you like to write down as an equation for the second function? If it was y equal to 0,
Y
and we are lifting that, it was merging with x-axis because it is a horizontal line, y equal to 0. Now we are lifting this 1 unit up. What would be new equation?
Y equals 1.
Absolutely correct. Definitely. Yes, guys. Thank you for your help. Oops. So I am writing this down. Now, I would like to mention something important also about range, because range is also very important for all functions. Definitely, we have many more properties, but I decided to talk about main properties. For the function y equal to 2 times 3 to the x, horizontal asymptote was x-axis because b here is greater than 1. The function is actually increasing, means the top tail moves to a positive infinity forever, but the lower tail, it moves closer and closer and closer to x-axis when we have axis running to negative infinity, which is absolutely normal because domain is a set of all real numbers. Y value is moving closer and closer to 0 from the top. This y, when we talk about the range, can we say for that function 2 times 3 to the x, range is all positive numbers?
Yeah.
Yeah.
So which means it will be open end at 0, no bracket. It will be 0, positive infinity. 0, positive infinity, all positive numbers.
Yes.
Don't please do anything which can remind you a bracket, because bracket means 0 would be included, and it is not the case. Now, what can we say about the range? Is it a range about the vertical change of the function?
Yeah.
So if we have that function with vertical shift, actually as it is a result of lifting our previous function 2 times 3 to the x 1 unit up, so which means vertical change also will be changing. It sounds a little bit funny, vertical change, because range is about vertical change. In your opinion, what would be the new range for that function which had a vertical shift? Can you help me, please?
1 to infinity.
And with this one, is it a round parenthesis or a bracket?
Round.
Round parenthesis. Absolutely, yes. Yes, yes. Did you write it down?
Yeah.
Yeah.
So, and if we like to have quite rough graphs for these functions, I'm going to do dashed one for function without vertical shift, and the solid will be for desired function, which was in our textbook. So practically, again, y-intercept occurs at the point 0, 2. It is increasing function, definitely. We have that type of graph. I did it with dashed curve. Oops. The second one, I'm going to migrate with the asymptote. I'm going to show asymptote first. It is a horizontal asymptote, and it is point where y equal to 1, 2, 3. 3 is new. 0.3 is the new. Y-intercept. And I actually will write down here the equation y is equal to 1. Y is equal to 1. That's it. And I really recommend you all the time when you need to build the graph of functions, specifically functions which, in your opinion, should have horizontal or vertical shift, to list first main properties of that functions, and after that, as a result of that, actually sketch your graph. But at the same time, I need to admit that in many cases, when these functions have very complicated equations, a range can be, let's say, mentioned as a last step, even after you have a graph. But definitely domain all the time should be your first step, because you need to know what kind of values of x you can legally use for that particular function given by its equation. Is it clear?
Yeah.
Yes.
And I would like to offer one more, and after that, I will go from that, but I will let you choose. Would you like to have number 13 or 14? I don't mind. Which one?
14.
14. Okay. 14. Original function here in the textbook is here natural log of x plus 1. Is it a natural log?
Yeah.
Yes.
What is the base? Is it e?
Yeah.
Yes.
Base e, is it greater than 1?
Yeah.
Okay, so which means now I have this basic information, and now I will think about a cousin of that function, which can help us very easily to mention here properties and to build the graph. What would be the cousin of that function which can help us? Which function? Do you need my help?
Is it log?
I cannot hear, I really apologize.
Is it log?
Definitely, it is a logarithmic function, which means we need to choose one of cousins of that function, which is very close to that.
Okay.
Basically, it should have a graph parallel to that. At the same time, I already can see, and I think you will agree with me, that this function, which was offered to us by the textbook, does not have a vertical shift, right?
Mm-hmm.
But can you see in parentheses, instead of just natural log of x, do you see natural log of x plus 1?
Yeah.
Yes.
Yeah.
What should click in your mind? This one definitely should have a horizontal or so-called phase shift. And you can be even more specific. Is it x plus 1?
Yeah.
Yes.
So in what direction should we move horizontally? To the right or to the left?
Left.
Yes,
Left.
because it will be moving all the time into direction opposite to the sign which you have in parentheses. If I had here natural log of x minus 1, so it would be 1 unit to the right. If we have, as we have here, natural log of x plus 1, it will be 1 unit to the left. But now, 1 unit to the left from what kind of graph? What is the cousin's graph formula? Is it natural log of just x?
Yes.
Yes.
Your voices, they sound a little bit suspicious, as I say. It looks like you are not completely sure. Do you need any feedback for that? The basic simple functions formula for logs with base e which is natural log, is natural log of x, definitely. This is the best cousin of that function, y equals to natural log of x. And now we already have same type of logs, they have same basis, the only one does not have any shift, the basic function natural log of x. The second one is having only phase shift. And what I'm going to do under each of these formulas, I will try to mention right now properties of these functions. So let's start with the simple natural log of x. Domain. This one has domain equals to what kind of set, ladies and gentlemen? Can I have under natural log or any actually log with any base 0? Do you need my help?
Mm-hmm.
No, guys. Log of 0 is undefined. Log of any negative number is undefined. This is why last time we talked about graphs of logarithmic functions. They will be, if they don't have phase shift, they will have entire graph on the right side from y-axis. It means that this time domain equals to all positive numbers. So this is why the domain for natural log, again, the function which does not have any phase shift, domain all the time for regardless of the base, less than 1, greater than 1, because base cannot be equal to 1. Base can be equal to any positive number. The entire graph will be on the right side from y-axis. And beside that, what would be its actually inverse function? Inverse function for y equal to natural log of x is y equal to e to the x as an exponential function. And domain for that exponential function will be working as a range for this logarithmic function. And the range for that exponential function y equal to e to the x, it will work as a domain. So this is why you can keep this in your mind, this type of relationship between inverse to each other functions. Now, can we say that, let's say, domain for the y equal to natural log of x plus 1 is also interval from 0 to positive infinity? No, we cannot, because domain is about horizontal change of the function. And here we have horizontal shift, and this shift is 1 unit to the left, horizontal or phase shift. Phase shift. 1 unit to the left, or you can write just -1. Both are legal. This is why we need to define the domain. The easiest way, definitely, I can do that shifting that interval from 0 to positive infinity 1 unit to the left. Is it legal? Yes, it is. But I think even much easier will be this following actually method. You need to set up this inequality. X plus 1 should be greater than 0, and solve it for x. Simply moving that positive 1 to the other side, it becomes -1. So x is greater than -1. And now I'm ready to write down that domain. Domain will be interval from -1 to positive infinity. If you compare D1 with D2, you can easily see that actually D2 is the result of shifting D1 1 unit to the left, because that end at 0 just moved to the left 1 unit, and now it has the border of x here at -1. So now, what about x-intercept? And again, if you like, you can have the same actually inequality for the function. You can see I wrote here for right here, x is greater than 0. Now let's talk about nature of that functions. The base of that log is greater than 1. Both functions will be increasing, which means they will be presented by the curve, which will be moving more up, and more up as we move from left to right on XY coordinate actually plane. At the same time, we need to say something about x-intercept, because again, first function y equal to natural log of x did not have any y-intercept. But what happens here? I actually will provide right now the graph for natural log of x. And I'm going to do that also in the dashed form. It is quite important to say something right away about x-intercept. X-intercept will be at the value x equal to 1. X equal to 1. You can see the nature of that function, it is increasing. Now, y-intercept, no. X-intercept for that function, it is 0.1. If we write this in full version like ordered pair, it is at the 0.1 comma 0. But it is about x-intercept. If we have horizontal shift, it moves horizontally or to the right or to the left. In our case, to the left. What happens with that x-intercept if we look at this x-intercept from the point of the view of the equation for natural log of x minus x plus 1, excuse me? Is it moving also? Guys?
Oh, yes.
Definitely. So, and if you horizontally move that point, which is 1 comma 0, horizontally 1 unit to the left, what is the new point?
Just
What is the distance between 0 and positive 1? Is it 1 unit?
actually,
Yeah.
yeah.
If you grab this and move it 1 unit to the left, what is the new position? Is it 0, 0 point?
Yes.
So this is your new actually intercept, because again, it moves 1 unit to the left. I actually can use the same XY axis to show now that graph. Again, we are parallelly moving that. The only, please first show vertical asymptote, because here the simple formula, it has y axis as a vertical asymptote. The new one, and I'm going to label each graph natural log of x. This one is y equal natural log of x plus 1. You are moving graph 1 unit to the left. You can see that vertical dashed line because we all the time show our asymptotes in the dashed form, because it is not a part of the graph itself, but it is a limit for a limitation for the graph, like a border for the graph. So This why I can easily right now write equations. So vertical asymptote for the first simple function is x equal to 0. Vertical asymptote for that function, which is in the textbook, is x equal to -1. And now we are actually ready to provide the last thing, range for both functions. Do you see any vertical movement here?
No.
Does it mean that we can say that both ranges should be identical?
Yeah.
Yeah.
Because there is no movement up or down which can change something in the vertical change, definitely. So it is set R, set of all real numbers for the first function and for the second function. And this is quite complete investigation about both functions. And definitely there are many different methods also, but this is the easiest method to choose the cousin function for the given function. And after that, adjusting some properties of a function which has easier equation to get properties and graph of the function which has more complicated form of the equation, but which belongs also to the same family of functions. And this is approach, this type of approach is being used not just for exponential functions and logarithmic functions. We widely use this for all other functions, specifically, let's say, in trigonometry, which we are going to talk about a little bit later. Okay. This is what I wanted to talk about, comparing graphs of both functions. Because we just right now talked about geometric properties of functions, I like to offer you another problem from the same section on page 214, unless you have some questions which you like to address to me. I'm ready. What about these details? Were they clear to you?
Yeah.
Yeah.
Can I
Yeah.
move to another problem?
Yeah.
Okay, so I'm going to remove these papers. We don't need them anymore, I hope. And I will tell you about another problem right now. This new problem will be from the same section, but this is page number 213. 213. And I would like to offer to you right now problems number 52 and 54. While you look at these problems, I will try to call some names again. And after that, I will also join your company. Again, page number 213. Let's first start with problem number 52, and after that, we will work with problem number 54. Just 1 second, please. Christian? Gabriel?
Here.
Kobe? Ricardo? Hochito? Matthew? Okay, that's it. I'm not going to read this anymore. So, and let's see what we have in this problem. Give the domain of, and here we have a function which is here with its equation. Y equals fractional line 1 over 2 minus square root 7 minus, is it e to the 2x, guys?
Yes.
Or it is
Yeah.
t? I think it is t,
T.
right?
T, yeah.
Okay. So this is that function.
Yeah.
I hope you copied this from the textbook. Can you please try to name that function? Does it have a fractional appearance?
Yeah.
Yes.
Can we say that this is type of a rational function?
Oh yeah.
Yes.
At the same time, what do you see in denominator? Do you see we have here a square root?
Yes.
Mhm.
Can we say that this function is actually result of intermarriage of rational and irrational functions,
Mm-hmm.
Yes.
right?
Yeah.
Mhm.
So which means we need to consider properties of both families. What would I do if I were you? Do you know that for rational functions, denominators, they play tremendously important role?
Yeah.
They should not be equal to zeros, right?
Mm-hmm.
Mhm.
So start with that. 2 is not equal to what? Square root 7 minus e to the 2 to the t. Which eliminates 0 in denominator. It is not 1 over 0 anymore because 2 is not equal to that square root. But we are looking for the domain, and domain here can be quite complicated. This is why we need to simplify this, actually what we just wrote down. And you can work with that piece like you would work with regular equation, only instead of regular equal sign, you will be writing not equal. Can we square both sides
Yes.
Yes.
Yeah.
to eliminate the root? Yes, so square it. Is it 4 not equal to 7 minus e to the 2t?
Yes.
Mm-hmm.
Can I first solve it for e to the 2t and after that for t? Can I move 7 to the left?
Yes.
So 4 minus 7 equals negative e to the 2t. 4 minus 7 is negative 3 equals negative e to the 2 to the t. We are very lucky that we have negative on both and on both sides. We can simply divide by -1 or multiply by -1. It is up to you. And we are getting here 3 not equal to positive e to the 3 to the 2t.
Yeah.
So far, so good?
Yeah.
Yes.
Excellent. Now, what should you do? Should we solve it for t? What would you do if you had here regular equal sign? Would you log both sides?
Yes.
Yes.
Natural.
If what kind of log?
Natural law.
Absolutely correct. So it will be natural log of 3. With your permission, can I skip maybe one step? Can I immediately write that it will be not equal to 2t?
Yes.
Yes.
Okay, not equal to 2t. Because if we like to show all steps, so it will be natural log of e to the 2t. 2t comes down to the front of the log, and we have 2t times natural log of e. Natural log of e is 1. So basically, we got this. Can we divide both sides by 2?
Yes.
And what do you get? You are getting t is not equal to natural log of 3 over 2. Or if you like, t is not equal to 0.5 times natural log of 3. And you know what? It will be not bad to approximate this value so we will know what is going on. Because definitely we will try to write down the domain using exact values. But I like to know what the approximated value is. So 0.5 times natural log of 3. And let's approximate, let's say, to the nearest 1,000. What did you get, guys? Did you get the same number? Ladies and gentlemen.
Oh, yeah.
Yes.
So 0.549, and I will store it. I will later come to this value. What do you think? What should be the next step here? Because I just used right now the property of rational family. But do you remember it was actually a mixture of rational and irrational?
Yeah.
Now it is time to use property of irrational functions, specifically when we have quite aggressive type of the root, because even roots are much more aggressive than odd roots. Should I consider that we are working in the set of real numbers, not complex numbers? In this case, what should I have under the square root sign as a radicand? Can I have a negative number under square root?
No.
Can I have 0?
Yes.
Mhm.
Can I have positive numbers?
Yeah.
Yes.
So which means this was part A in my search. Now I'm starting part B, and I'm saying that that expression which I had under this root, 7 minus e to the 2t, should be greater or equal to 0. It cannot be negative. And now I'm going to solve this inequality. So it will be 7 greater or equal e to the 2t. I'm planning to use natural logs. Natural logs are representing increasing functions, not decreasing. This why I will have same greater or equal sign. So it will be natural log of 7 greater or equal natural log of e to the 2t. Because again, the nature of the function natural log with natural log is increasing functions, not decreasing. Base is greater than 1. If I had here base less than 1, I would change that sign to less or equal. And just use logarithmic properties. What do I have? Natural log of 7 should be greater or equal to 2t. And here, again, divide both sides by 2. 2 is a positive number, so we do not change this symbol of inequality. So practically here, again, natural log of 7 divided by 2 is greater or equal to t. Or at the same thing, like I can say that t should be less or equal 0.5 natural log of 7. Do you understand where it is coming from?
Yeah.
Yes.
No questions?
Mm.
No.
And we already actually approximated. Can you see it as the same actually number? It will be approximately 0.549.
Yeah.
Mhm.
But now we need to combine both conditions. In the part A, what did we get? 2 cannot be equal to that number. Can you see?
Yeah.
Yeah.
At the same time, in part B, t should be less or equal to 0.5 and natural log of 7. So if we sketch that actually number line, what do you see here? Let's say we have 0 here and 0, and there is 1. So this point is somewhere between, let's say, a little bit closer to 1, passing the half distance between 0 and 1. Let's say this is the point, and this is the number which is 0.5 natural log of 7. I just showed this right here. And it should be, it is just my pen did bad job. It should be open circle. You can see probably. Do you see there is some space inside of the circle?
Yeah.
Yeah.
And now, which means, no, I cannot use this actually number itself now. What should I do? Can I actually move from that point, which you see between 0 and 1, to the left, because t is less or equal to that number?
Yeah.
Mhm.
I'm shading. Or you can use arrow. And actually, I'm ready right now to write what domain is for that function. Domain, can I start with negative infinity?
Yeah.
Open parenthesis, definitely from negative infinity up to 0.5 natural log of 7 if we are talking about exact value. If we are talking about approximation, you need to write that domain is approximately equal to. And voila, this is the domain of that function. Or if you like, natural log of 7 divided by 2. Or let's say 1/2 times natural log of 7. Or even you can write natural log of square root of 7, but I think it will be good enough because there are many different modifications. Unfortunately, there is no time left for 54. I wanted to talk about limits, but at least I can talk about at least one. What do you think would be the best match for part A? What do we have in part A? Let me write this down, number 54, part A. What do we have in part A? Limit x is approaching 0 from the right, which means staying greater than 0, of f at x equals negative infinity. And you have here 4 graphs, 1, 2, 3, 4. Can you choose problems, excuse me, options here? When x is approaching x from the right, and at the same time, tail of that goes dramatically fast down.
3.
I could not hear it. Can you repeat, please?
Oh, I think it's 3.
And you are
3.
absolutely correct, because option here is definitely number 3. So practically my answer is I here, because I just showed here. Yeah, this is that graph. So basically, look at where x is approaching to which number x is approaching, because here it says to 0 with the plus, it means from the right side, which means staying greater than 0 all the time. Because x can be approaching from the right, it can be approaching from the left. So, and I will probably start answering, checking to what kind of conclusion you came to at the beginning of tomorrow's lecture. Can I, with your permission, say that we can end our meeting today?
Yes.
Yeah.
Yes.
People do not sound enthusiastic, but some people say yes. Okay, thank you for being here today, and I'm planning to continue in the same manner to the end of semester. And tomorrow will talk you about more details about coming tests for 2 chapters about exponential logarithm. Everyone have a nice, beautiful day, and I will see you tomorrow, virtually, definitely. Okay?
Have a good day, Professor.
All right. Bye-bye.
Thank you, guys. Bye.